Okay, guys, I think we can start today's session. And as I mentioned, this session is about a topic called Docker. Okay, and let me show you the syllabus first. So, in the last session, last week, we have been discussing about Git. Okay, and then we have seen how to create a GitHub repository, how to push the code to it. I mean, the basic stuff. And I just started with the Docker last week, but I'm planning to like start with from the concept itself. Okay, then I will talk about the importance of learning this topic in a ROS course, and yeah, some of the basic stuff with this. Okay, it's not very complicated, only the basic stuff. Okay, okay. So hope everyone joined. Okay. Yes. So I will suggest you to have a look on this website first. Okay. Not now. I'm just sharing it. Okay. So they actually explained everything in a simple manner, and this is the official website of Docker. Okay. Okay. So I'm going to talk about the Docker concept. So before that, I just want to ask you a few questions. Okay, few questions. So how many of you try to like create a software and try to deploy that software in another computer? Like it can be a simple program, like a program that you have written in your computer, and you just deployed that program in someone's computer, okay, and make it work. Okay, so do you have any experience with that, guys? Anyone try to like deploy your software into another PC? Anyone try that thing? Okay, okay, fine. So if you don't have that experience, maybe I can just share something. Like imagine you are creating an application, say a robotics application. Okay, and you are creating that using ROS or any framework. Okay, and for that you have set up everything on your computer. Okay, and it's working fine on your PC. Okay, imagine your PC is running on Ubuntu 20.04. Okay, and your friend's PC, okay, your friend's computer is running on 16.04. Okay, I hope you are familiar with the Ubuntu versions. So your application will work on 20.04 with some dependencies, but this same application has to run on 16.04. Okay, so can you suggest a way to run my application that is running on 20.04, and I have to run it on a 16.04 Ubuntu version? So can you suggest a method, guys? Can you suggest some methods to run my application on another machine which is running on 16.04? Can you suggest? I mean, what are the difficulties that you are seeing? Anyone? Any idea? Okay, so if you don't have any idea, then I can explain. For example, if you build an application in one operating system, okay, it can be like it can be Ubuntu 20.04 or maybe Windows or like Mac, any operating system. Okay, then you will have, yeah, you will have some dependencies means like in order to run your application you may need C++, you may need Python, you may need OpenCV or some libraries. As Archis mentioned, there will be library dependencies, version incompatibilities, right? So if you replicate the same thing in another PC, then only this application will work. It's obvious, right? So how to replicate your application with the environment that you are working with in another PC. Okay, then only your application will work on the another computer, right? Makes sense, right? If you have any question, you can just comment, or you can ask. Okay, so in order to like deploy, okay, I'm using a word called deploy, which is like I am going to put my application on another computer. Okay, so one of the method for deploying my application on another computer is using virtual machines, right? I hope you are all aware of virtual machine. If you are not, I just want to show you the virtual machine. You may heard about the virtual box, okay, or VMware, which is nothing like, it's very easy. I can show an example. Currently, I am working from Windows, but I have a guest operating system which is in Ubuntu 20.04. Okay, so this is called the virtual machine. Okay, virtual machine is nothing but a software which is used to install another operating system on it. Okay, here I'm using a virtual machine software called VMware. Okay, and inside that I have installed a complete Ubuntu operating system. Okay, so I can work with Ubuntu and also Windows. Okay, and also I can drag and drop. Okay, so this is virtual machine. So in this way you can create a virtual machine on your friend's computer, and you can install 20.04 and you can set up all the dependencies, right? And then your application will work. Okay, can you say what are the limitation, what are the problems with this approach, like installing a virtual machine and installing a full operating system and then run your application? Can you see any problem with this approach, guys? With the virtual machine concept to run an application, to run a single application? Any idea? Are you finding, are you finding any issues with this approach? Okay, maybe I can mention the issues. So the issues are, in order to run your application, if you are using virtual machine, you are basically creating or installing a complete operating system. Okay, it will take like 8 GB, 10 GB of space. And in order to run your application, do you need Firefox? Do you need Thunderbird Mail, or do you need these Office tools or something? No, right? You just need an environment which can able to run your application. Okay, so what I am trying to say is that by using virtual machine for running a single application, it's not a optimized, or it is not a good method, because we are using lot of space for installing this operating system. We are using more CPU, and we are using more time. It's not very easy to install a virtual machine. It will take time. Okay, so these are the problems. Like if you want to install or set up your application on another computer with a different operating system, you will face these issues. This is a practical difficulty. Okay, and when will these problems comes to a robotics engineer? I can mention that. So if you want, if you are a robotics software engineer, okay, you are developing a software for the robot on your PC. Okay, and you are going to deploy, or you are going to put this same software on the robot. Okay, so the robot can be maybe it can be have another operating system, or with the same operating system, let's say. So if we want to make the process easier, if you want to deploy your software in the robot easier, then there is a method called Docker. That is what we are discussing today. Okay, so in the meantime, like Urvashi is having a question, why is it required to have this extra OS using virtual machine rather than main OS when we install? Yeah, so Urvashi, the thing is that um, the situation that I mentioned was, um, you build an application and your friends doesn't have the same operating system. Okay, it's a different operating system. So the application that is working on the main operating system that you mentioned on your computer will not work with the different operating system. Like currently if you're working with Ubuntu 20.04 and your friend's computer is having 16.04. Okay, so your application may not work because of the dependencies. Okay, so that's why I mentioned if the main OS doesn't support the application, then we have to look for some other alternative. So one of the option is installing a virtual machine which is having 20.04. Right? So is that clear, Urvashi? Is that clear? Okay, okay. So I talked about the problems with the virtual machine approach. So what we can take is another approach which is much more convenient and much more efficient. Okay, that method is called Docker. Okay, which is a technology, okay, like virtual machine. And using this technology, you can build your application, then you can share the application and you can run it. Okay, so the Docker is like very, I mean, the technology is almost similar to the virtual machine. Okay, but here we are actually using a different technique. Okay, in order to make the operating system lighter, in order to make the deployment faster. Okay, and in order to make the application, I mean, in order to scale the application. Okay, so Docker is what we are going to discuss and what I'm following is this tutorial. Okay, so I think you can also follow this. Okay, so I will be like talking first about like Docker, then we will try to see the installation. Okay, and I will explain each concept one by one. Okay, so about Docker, this is the official website. This is an open source technology. I think it's released on 2013. Okay, Docker released in 2013. And so what is the main application of Docker? The main application of Docker is like you can make a container. Okay, you can make a container. I think you know about the container, right? So inside this container, okay, the container is actually a software unit or a block, and inside this container block you can put your application, you can put all the dependencies, okay, and then you can share with others. Okay, so anyone with Docker can able to download your container, okay, or that package, and then anyone can run it. Okay, so basically you have to build that application with the dependency, and you have to create a file called image. Okay, you heard about the Ubuntu image or like Raspberry Pi image or something like that, the image file, right? So like that you can actually put all these things in a single file, okay, called image, and that image can be shared with others, and then others can download this image and run that image. Okay, so like this you can I mean work with any number of application, and others can like run it. Okay, so I know I mean the things that I have discussed was like very basic, but I will explain it while we seeing more concept. Okay, so just make sure that uh, like Docker is for application deployment. Okay, if you have an application, you can able to deploy that application in any operating system. Okay, so why we are learning Docker in a ROS course is that if you create a ROS package or ROS application, okay, maybe ROS object detection, ROS based object detection, you can deploy this application in a robot directly without much worrying about the dependencies. Okay, so this will be useful if you I mean work with bigger projects. Okay, so this session will be like a introduction for this technology. Okay, okay, so yes, and regarding the Docker support, Docker is primarily supported on Linux. Okay, and but it will also work with Windows and Mac. Okay, and there are some other terminologies related to Docker. I will explain that. But before that, I just want to show you how to install Docker on your computer. Okay, so we will be I mean focusing on the installation on Linux. Okay, currently we are using Ubuntu 20.04. Okay, so in order to install Docker on Ubuntu 20.04, it's just one command. Okay, it's just one command. Maybe I can just show you that. So you can use just a second. Actually, in my computer it's already installed, but I can show you the command for installation. Okay, just a second. Yes, so this is the command for installing Docker on Ubuntu. Okay, it's a single command. So it's a this is a easier method to install Docker on your computer. Okay, so yeah, so that is the installation steps, and I think you don't need to do all these steps. Just this command will be enough. Okay, okay, and yeah, so you can try that. You can try to install this same on your computer. Docker. So here it's already installed. You can try that. Okay, and there is an installation instruction of Docker in just a second. This one will be good. Just a second, guys. Let me mute my mic. Just a second. Okay, so I think this is one of the tutorial that I am following. Okay, so I think this is having most of the things. Just a second. So basically after installing Docker, you have to like run these things. Okay, and important stuff is this is very important. I can just mention this command. Yeah, so Urvashi, like this session is getting recorded, so you can follow after this. Okay, no problem. Okay, I'm just showing it now. Okay, yeah, so so this is how we can install Docker. I think these 2 lines of code will be enough. I mean 2 lines of command will be enough. First is snap install Docker, then you have to add the permission for the user to the Docker group. Okay, and after that you can either reboot your operating system. Okay, and if everything is working, you can just just show this, just enter this command called docker space version. Okay, docker space version. I can just copy paste this command to the Discord. Okay, so if everything working fine, you can able to find the version of Docker, then the engine version, then all this stuff. Okay, if there is any problem with the permission, then you will get an error like you may can see the version, some version, but you can see got permission denied or something like that, socket permission denied or something like that. So make sure you have executed this this command. Okay, so if you execute that command, I think that permission will go. But if that even after the command, if you execute if you are getting the permission issue, then you can just paste into the Discord. Okay, we can solve it. Okay, so yeah, so what is the role of user? I can explain Vashi. So basically the user means the current user. Okay, maybe I can just show you that. So if you execute, oh, just a second. So what is happening is that this user, okay, this is actually the current user. Okay, so this is how we are accessing the environmental variable. Okay, so there is a variable called user in Linux. Okay, it's a default variable. Okay, and in order to access that variable, you can use dollar with the parenthesis. Okay, and what the variable having is the username, current username. Okay, so what we are doing is we are adding the current user into the Docker group. Okay, so then only we can, the current user can able to work with the Docker command. Okay, so basically using this command, we are giving permission to our user to use the Docker. Okay, Docker commands. Okay, so otherwise we have to use the sudo space Docker. Okay, that will also work. Okay, is that clear, Vashi? Okay, I think okay, great. Okay, so that's it. That is the installation instruction for Docker. Maybe after the recording, after the session, you can try. If you find any issues, you can reach out me in Discord. Okay, so so that is the installation step. And now I just want to introduce the concept of Docker images. Okay, Docker images. So I mentioned that in order to deploy your application, you have to package your application in a file called images, Docker images. Okay, so you can build an image basically. Okay, for example, you have an application, you have a source code for object detection, so you can build an image. Okay, so in that image you should need Ubuntu 20.04, you should need maybe OpenCV, and you should need your source code. Okay, so this image contain all the setup that required to work, that is required to run your application. Okay, so image is actually having all these things. Okay, the operating system, the dependencies, and your application. Okay, so you may be thinking like, if we include a complete operating system on the image, then the size will be also high, like the VirtualBox or VMware, right? But In case of in the Docker operating system, okay, we are not using the complete operating system. Okay, we are not using the complete operating system. Instead of that, we are using a lightweight footprint of the operating system. Okay, for example, if you need Ubuntu 20.04, what you will get is you can download an Docker image of Ubuntu 20.04, which is having only basic stuff like kernel, then the basic terminal, all those stuff. Okay, so if you just go to this website, okay, it's called Docker Hub. Okay, Docker Hub. So let me sign in, then you will understand. Okay, just a second. Okay. So you are working with the GitHub, right? So what are the things happening in GitHub? We are basically like having the repositories, right? And you can able to like push something on the repository, pull something. Okay, you can like see others repository, right? So you are aware of GitHub. So Docker Hub is very similar. In Docker Hub, what we have is Docker images. Okay, and you can, I mean, clone these Docker images. You can push your Docker images to the Docker Hub. You can modify. Okay, you can compare GitHub and Docker Hub. In GitHub, we are working with a repository, code repository. In Docker Hub, we are working with the Docker images. Okay, and using Docker, you can build an image and you can push or upload into the Docker Hub. Okay, and if that is public, then everyone can see your image and you can and download it. Okay, so the image concept in Docker is like, it is actually a single file which is having the application, operating system, then the dependencies. The operating system will be lightweight. It will be only having 50 MB or 60 MB. Okay, but the full operating system will be like 5 GB or 6 GB. So you can see the difference. Okay, so your application can be packaged. Maybe for example, in an object detection application can be packaged in around like 150 MB or 200 MB size. Okay, in that image you will get an operating system, dependencies, and application. Okay, and now so I think you got a basic idea of the Docker images. And as I mentioned, the Docker Hub is the area it's a hub of Docker images. And if you want to find an image of Ubuntu, okay, for example, if you just search for Ubuntu, then you will get the official Ubuntu Docker image. Okay, so you can find here, you can find 18.04, 20.04, 16.04. okay, so imagine if you want Ubuntu 20.04 Docker image, then you can download or pull it from here. Okay, so for building or packaging your application, if Ubuntu is one of your dependency or one of the dependency, then you can include Ubuntu on your application like this. you can actually add any Ubuntu version, okay, mentioned here, okay, into your application. Okay, and then after downloading Ubuntu, you can install necessary dependencies, and then you can run your application. Okay, and also if you want to directly need a ROS Docker image, then that is also there, you can able to see. So this is where the Docker will be super helpful. So while working with ROS, there are different distributions in ROS. Like currently we are working on ROS 1 Noitic and ROS 2 Foxy. Okay, but there is ROS 1 Melodic, then ROS 1 Kinetic. Okay, so imagine if you want to run the same application on Kinetic or Melodic, then the only solution is using Docker images. Okay, so you can find the Docker images of Melodic, Noitic, then Foxy, Galactic. Okay, so you can simply pull these Docker images, then run your application and then package it. Okay, and then upload again into the Docker Hub. Okay, you can either keep your own Docker image on your system, or you can upload into Docker Hub. Okay, so that is what actually happening. So in order to build your application, you are like taking the existing Docker images, then adding the, modifying or adding the dependencies and running your application. Okay, same as the VirtualBox. So if you run an application on VirtualBox, what will you do? You will be like downloading the Ubuntu image, right? Ubuntu 20.04 desktop image. Then you will install the dependency. Okay, then you will run the application. The same workflow for the Docker image. Okay, you will pull the or download the Docker image, install the dependency, run the application. Okay, yes, so that is the Docker Hub and Docker images, which is very important. And you can find the official images from these kind of official images, ROS official image, Ubuntu official image, and also like OpenCV. If you search for OpenCV, then I think you will get some good images, Docker images, and you can simply use that image for running your application. Okay, so it will be very fast. It will not take time like the VirtualBox or VMware. Imagine if you want to run your application on OpenCV 4.x, then simply download this image and then run your application. Okay, and you can see the download count here. So around 10k plus pulls. Pulls mean simply download. Okay, and if you want to pull this image, maybe I can show you that. Maybe just a second. I just want to pull a ROS image. Okay, there is a question. Okay. Okay, so I think the Docker image is not clear for Urvashi. Maybe I can explain it again. So Docker image is simply a file. Okay, it's simply a file, and actually, if you want to create a image, okay, or if you want to build a image, custom image, there are some existing images available on Docker Hub. Okay, like it's actually a file, and that is available in Docker Hub. And if you want to build our own Docker image, then there are some methods to build it. Okay, so first, in order to imagine, I can give an example. I need to build a ROS application. Okay, so what I will do is I will download the official ROS image. Okay, ROS image. Okay, then I will run my application on it, right? And then I will build it and then create a new image which is having my application and the ROS image. Okay, so it's a combination of this image and my application. Okay, so Docker image is it's actually a file, just a file. Okay, which is having the application, operating system files and its dependencies. Is that clear, Urvashi? Okay, Okay. So yeah, yes, so we have seen the hub and the images. Okay. And maybe as an example, what I can show you is that the very basic example for an image. Okay, an image. So if you go to the Docker Hub, okay, you have to actually create an account in Docker Hub. So if you just search for hello world, so this is one of the example image present in Docker Hub. Okay, it's called hello world. Okay, and so basically it is having a Linux operating system. Okay, Linux operating system, and then it will print hello world. Okay, so I can show you that. So basically, in order to download this image, I just want to copy this command into my terminal. Okay, so I am actually downloading the hello world. Okay, okay, so you can see it's actually pulling from library, and yeah, so seems like the image is downloaded, and there is a command called docker. That command is actually getting if you install Docker application on your computer. Okay, so if you simply enter Docker, then you will get a very big help or usage manual along with that. Okay, so in order to like list out the images on your computer, Docker images, you can find here, like you can just enter Docker space images. Okay, if you do that, you can find the hello world. Okay, which is the latest image that we have downloaded, and I already downloaded Ubuntu and also ROS. Okay, so these three are the images that is available. Okay, so you can find the hello world image is having 13 KB size. Ubuntu is having 72.8 MB. So just imagine the basic Ubuntu operating system is available in 72 MB. Okay, and there is ROS image which is like 1.24 GB. Okay, but it's very less than, I will say 10x less than the size that we are using in VirtualBox. Okay, so 1.24 GB image which having Ubuntu, then ROS, the ROS desktop full installation, everything. Okay, so if you want to basically run a ROS application, just pull the ROS image, then just run it. Okay, okay, so so the next question is, so we have talked about the images, then what's next? What's next? So that is the question, right? So if you check the virtual machine, you have installed the virtual machine, then next is running it, right? Running it. So the outcome of running a virtual machine is you will get the full operating system like this. Okay, you can work on it. So that is what we are doing with Docker now. Okay, what we are doing is we are going to run this image. Okay, run this image. Okay, so the first example that I am showing is a demo. Okay, so if you just run docker space run hello world, so the run is the argument for running an image. Okay, so docker space run space the image name. Okay, so this is the image name. If you do this, it will print hello from Docker. This message shows that installation appears correctly. Okay, okay, so what we are doing is using the run command, we are running this image. Okay, so when you run the VirtualBox installation, you will get the operating system. When you run the Docker image, you will get the same. Okay, so this is the dummy image. Actually, when we run it, it will just print hello from Docker. Okay, and it is having some Linux basic Linux operating system. Okay, but just ignore it. Okay, this is just a dummy thing to demonstrate run command. Just focus on Ubuntu image. Okay, so we are going to run an instance of Ubuntu now. Okay, an instance. Okay, instance means we are actually going to run an Ubuntu operating system using Docker. Okay, so this is the command docker run it ubuntu bash. I will explain it. So docker is the command that we are using, and run is for running an image, and -it is called interactive, and bash is the bash terminal. Okay, so the output of this command is it will start Ubuntu image. Okay, it will start an Ubuntu image, and when an image start, it is called the container. Okay, I mean, we are starting an instance of the Ubuntu image, okay, which is called the Docker container. Okay, currently using run command, we are starting a container from the image. Okay, so like the VirtualBox, we are actually running the real operating system, right, from the installed files, right? So similar to that, from the image we are running the operating system now. Okay, and it's called a container. Okay, so from the Docker logo, if you check it, you can find the containers. Okay, so you can find in the logo, you can find the containers. Let me show you that. See this logo. Okay, so containers literally means each containers, okay, each containers are a running instance of an image. Okay, so what happen when you run an Ubuntu image? You will get the Ubuntu terminal or Ubuntu environment, right? Okay, so in this Ubuntu there is a speciality, not like the Ubuntu desktop or something. This Ubuntu is a very lightweight version Ubuntu, which is only having the kernel. Kernel is the core part of the operating system. I think you know or you heard about the kernel, and also the terminal application, basic things. Okay, only 72 MB size. Okay, so when you run the Ubuntu image, you are creating an instance of the operating system. Okay, that is called the container. And when you mention bash, okay, -it bash, then after running the Ubuntu image, you are opening a bash terminal. Okay, so this is the terminal from Ubuntu, not from this Ubuntu. You can see the difference. This is actually different. If you just check ls, you can see the difference actually. This is not my PC. I mean, maybe I can just show you that. So here in my real PC, in my desktop, this much of files are there, right? But if I'm going to this thing, I can show you that there is nothing, right? In the home folder there is nothing, but in my home folder there is a folder called robot. Okay, so what I'm trying to say is this is an instance of the Ubuntu operating system called container. Okay, so this is a container, and then you can do whatever you want to do. You can run the application or you can install the dependencies. Okay, so let me just try some commands. I mean, if you know the Linux commands, then you can try it out. So only very few commands will be available because it's a lightweight version, right? So maybe I can let me try with Nano, which is actually the text editor. So what will happen? Okay, it's saying Nano not found. So I can install Nano using this. Yeah, I think apt update you can do. It's updating. Yeah, so the problem is with this image, it only having the basic components, very basic. So it will not have that text editor, it will not have the desktop environment, it will not have, I mean, any tools, very basic things like the kernel part and some of the command line tools, command line commands. That's it. Okay, so currently I can show you how to install an dependency in this container. Okay, yeah, so currently I'm doing the apt update. Okay, apt update, and then yeah, so you can see it is progressing. Okay, so we are discussing this point, containers. Okay, so we try to like I mean run operating system, that is Ubuntu. Okay, now we are seeing with the package installation. I think it will take some time. Okay, so in the meantime I can show you this command, docker space ps. Okay, which is basically showing the running instance of images called containers. Here you can see containers ID, what is the image name, then what is the command, and the status, okay, and the container name. Okay, so I mentioned that Ubuntu instance is running, right? So you can find the current instance of Docker using docker space ps. Okay, so that is the container ID. This is a container ID and this is a name. Okay, so if you want to like get another terminal for the for the running Ubuntu, you will get it. I can show you that. So currently I can just install an application called Nano. So you can see the Nano is getting installed on our container. Okay, Nano got installed, and now I can just type it in the terminal. I can save it. Okay, currently you can see a file actually created called test. Okay, and in order to access another terminal, in order to open a new terminal for the same container, what I have to do is I have to like copy the container ID, then using the container ID, maybe I can just copy paste this command in Discord. So in order to get another terminal of the current container, or you have to use a command called exec. Okay, in order to run an image, you have to use docker space run. Okay, so that is a different. So this is called docker exec space -it, then the container ID, and also the application that we have to start. Okay, So now if you just check slash home, just a sec, you can find the test here. Okay, so currently we are working on a Ubuntu instance. We only have the command line. Okay, we only have the command line access, and you can do whatever you want to do, like you can run application, like you can set the dependencies. Okay, you can set the dependencies and you can run it. Okay, so that is this page says. Okay, uh, I know that you will have confusion. It's actually a very big topic, but I will get back to that one by one. Okay, so just understand that currently you are working on an Ubuntu operating system, an instance of an Ubuntu operating system. Okay, and yeah, so that is the thing. And one more thing, just a second, Docker images. Let me run Ubuntu again to bash. Okay, so what I did was, in these two terminal, I am running one instance of Ubuntu. Okay, one instance, I mean one container. Here I actually started a second container. Okay, using the run command I am creating a second container. So just do the docker space ps, so you can find we are running two containers now. Okay, so at the same time, we can run many instances of the same image. Okay, so two containers are running on the same machine. Okay, so you can run many applications at the same time in different containers. Okay, like you can create an instance of the same image, or like if I want to create an instance of this one, or if I want to create a container of rows, just use rows bash. Just a second, you have to mention the complete tag like this, rows noitic robot. Okay, so now I have another container which is running, which is having rows. Okay, so what I am trying to show you is that, like virtual machine, we can start multiple operating system. I mean, in virtual machine that is possible. Like that, in Docker you can start many operating system. Okay, many containers, that is the word. So you can check the number of containers. There are 3 containers. Okay, one is with the rows, one is with Ubuntu, and one is again with Ubuntu. Okay, so maybe I can start a demo, show a demo with rows. I know some of you don't know rows, but maybe I can just show you like a command called rows core, which is actually running from the container. Okay, it's not running on my PC, not in my real PC, it's running from the container. Okay, and I can just copy the container ID, then I can get another terminal of the rows container, and then I can use rows topic list. I'm not sure, we have to source it. No need to worry about this. If I do, then I can get the topics and all. Okay, and maybe I can publish a topic. I mean, these all are some demos. If you are not aware of the rows terminologies, just leave it. But just check whether we can work like all this stuff using Docker. Okay, currently what I am doing is I am just publishing a topic manually. Okay, the topic name is test. Okay, and it is publishing a string called hello. Okay, so I can just subscribe it. So for that I am just uh, taking another terminal. Okay, then sourcing the entry point, so which will source the rows environment, and then if I check, I will get the test topic. Okay, and if I do the rows topic echo, then you can see the topic publishing from this terminal is showing here. Okay, so basically if you want to work with rows, okay, you don't need virtual machine. Okay, you can straightly work from a Docker image. Okay, so but the thing is you have to know Docker. That is the difficulty. Okay, so I think I have discussed many topics today regarding Docker. So I have talked about the installation, then Docker Hub, Docker images, Docker containers. Okay, and at the end I just want to show you the Docker architecture. Okay, then we can do the Q&A. Okay, so maybe tomorrow I will discuss the building of images, then Docker compose and all. Okay, so here if you check the architecture of Docker, this is the architecture of a virtual machine. Okay, in the last class I think I have explained it. So in a virtual machine, you have a computer or a server. On the server there will be a host operating system. It can be Windows or Linux, and on this operating system the virtual machine is having a software called hypervisor. Okay, which is actually helping us to install the guest operating system, and on the top of the guest operating system we are installing our own app, or we are setting our own application. So this is how a virtual machine works. Okay, but we already discussed the problems with the virtual machines. It will consume a lot of CPU if you run multiple instances, and we don't need the complete operating system. I mean a lot of stuff like that. And here is the architecture of the Docker. Okay, basically we are installing a host operating system on a computer or a server, and an operating system is installed with a Docker engine. Okay, Docker engine, and the Docker engine is directly hosting our application. There is no guest operating system. Okay, so that is the main difference. Okay, so there is a question, how many OS can run in Docker? So there is no limitation for running, but the only limitation in running is the system resources. Okay, RAM, CPU and all. Okay, so when you run a container, okay, it will consume some amount of RAM, right? For example, if I am running currently, I can just show you the CPU resource using a tool called HTOP. Oh, HTOP is not installed. Maybe I can just check with the system monitor. So here if you check the resources, it is like it's taking like 1.5 GB of memory. Okay, yeah, so when you keep on starting containers, okay, then this memory consumption will gradually increase, and also the CPU consumption will also increase. Okay, so there is no no limit. It's purely the computer resources. So if you have enough resources, you can run many Docker containers. Okay. Okay, so I think we can stop here, this point. We can stop here, and tomorrow we will be like discussing about how to build an image, custom image in Docker. There is a thing called Docker file, which is very important, and there is a thing called Docker Compose. We will also discuss that. Okay, so in the meantime, if you can follow the current instructions for installation and the Docker exec, all those stuff mentioned in the video, it will be great. Okay, and tomorrow we will be discussing other stuff. So there is a question from Hari: is serial communication possible with the Docker container? Yes, it is. So basically, it's actually an operating system running on Docker, and we can expose the serial port and the Ethernet, everything from Docker. Okay, so that actually, I mean, is slightly an advanced topic, but again, we can expose all this stuff, and you can interact with Arduino or like other serial devices to the Docker. Okay, and the question, next question, that is very important actually. Tejas is asking, can we interact in GUI inside Docker? So the question can be like, can we start GUI application on Docker? Yes, that is also possible. There are different I mean there are some more commands to get I mean Gazebo and all in Docker. Okay, so it's in the official documentation as well. If you just search for Docker rows, you can find this tutorial. Okay, I actually work with rows, Docker, and Gazebo. So when you start the Docker container, you can run the Gazebo. Okay, so here are the tutorials for running rows on Docker. Here you can find Docker Compose, then using GUI with Docker. Okay, so here there are methods using Xserver and VNC. You can select. Okay, so Xserver will work. I have already tested that. Okay, so yes, so you can simply run the Gazebo simulation from the Docker itself. Okay, so there are many things that we can do with Docker and rows. There are many tutorials in YouTube regarding that as well. So imagine I can say an experience with rows and Docker recently. I think last year. There is a competition from IISc Bangalore called Art Park. So I was one of the mentor for one team, and regarding that challenge or competition, the organizers told to the team that you have to package all your software in a Docker image. Okay, and you have to give the Docker file. Okay, so basically the Docker file, if you have the Docker file, you can build a custom Docker image and anyone can run it. Okay, so basically if you want to run an application in any computer, you just need the Docker file. So in that challenge, we have to provide that Docker file. Okay, then they will run it, and all these things, the Gazebo, RVs, and everything comes. I mean that will run when we run the Docker image. Okay, so that is the application. Like if you want to deploy a GUI application or like terminal based application, Docker is one of the I mean efficient way, I will say, and it's using everywhere now. Okay, so now I think we can do a 5 minutes Q&A. Okay, if you have any questions regarding the basic stuff mentioned today, let me know if you have any questions. Do you have any more question, guys? You can ask any question, or after watching the video, if you have any question, you can also like mention. Okay, so I think that's it about today's session. I know that this is a very new topic for most of you, but just understand that these topics are very important while working with ROS. Okay, so that's why I included this. So some of the I mean some of the people from LinkedIn actually asked me like why you are including. Oh, just a second. Just a second, guys. Yeah, yeah. Okay. So yeah, I think there are some issues happen. So uh, some of the students from LinkedIn actually ask why you added Docker on the course. So I actually talked about the importance of the deployment of the robotics application. So this is very super important concept for you while working with um, ROS application. You have to write a Docker file for your project so that anyone can build a Docker image for your application and run it. So that's how we are running or deploying your application in another PC. Okay, this is one way. This is an efficient way of deploying your application in another PC. Okay, so if you have any question, you can get back to me. And yeah, so that's it for today. So tomorrow we will be continuing with the Docker file and Docker Compose. In the meantime, if you can practice these basic commands, that will be great. Okay, and if I get time, I will be starting with the portfolio building as well. Okay, okay then, guys. Good night and see you tomorrow. Bye. Bye, everyone.